Imagine if we have a microscope with the highest magnification power on Earth. Then we use it to zoom in into any matter. What do you think we will see? Assalamualaikum and good day everyone. Welcome to Siri Bicara Kimia Awal. In this video, we are going to explore the world of tiny things. They are so tiny that we can't even see them under the conventional microscope. The tiniest particle that made up everything in the universe is called atom. So what is atom? The word atom is derived from a Greek word atomos, which means cannot be cut. This word is used to describe the smallest unit of a chemical element or compound. Let's use an imaginary optical instrument to see the structure of an atom. When we zoom in into an atom, what we will see is mostly empty space. This empty space takes up 99.999999996% of the volume of an atom. The remainder of that volume is occupied by even tinier things called subatomic particles. An atom is made up of 3 subatomic particles called proton, not just proton, so we have proton, electron and neutron. Now, if we look at this illustration, we can see that the protons, the one with green color, and the neutrons, the orange ones, are concentrated in the middle of an atom called nucleus. Almost all the mass of an atom is concentrated in the nucleus, whereas the electrons, the blue region, move around the nucleus. The electrons are not illustrated because they are so tiny compared to the nucleus. The mass of subatomic particles is extremely small. If we refer to the table, a proton has a mass of 1 AMU, a neutron is also 1 AMU, meanwhile an electron is 1/1840th of the mass of a neutron or proton. As for the charge, electron has the relative charge of -1, proton is +1, and neutron has no charge. So now that we have described the subatomic particles, let's have a look at the significance of these subatomic particles and how they are represented in a simpler way. The following diagram shows how 3 different elements are represented in a periodic table. This format is called isotope notation, which is used to represent an atom. These letters represent the element symbol. O represents oxygen, F represents fluorine, and Na represents sodium. Then, these numbers represent the sum of protons and neutrons in the atomic nucleus. These numbers are called Nucleon number, which is also known as mass number. 16 for oxygen, 19 for fluorine, and 23 for sodium. And these numbers represent the number of protons in atomic nucleus. These numbers are called proton number, or it is also known as atomic number. 8 for oxygen, 9 for fluorine, and 11 for sodium. In general, elements are represented by using isotope notation following this format, where X is the element symbol, A is the nucleon number, and Z is the proton number. Did you notice that for these elements, the proton numbers are different? This is because an element is defined by its proton number. This proton number affects how many electrons are present in an atom. For these examples, the atoms carry no charge because they are neutral. Thus, the number of protons is equals to the number of electrons. But what about the particles that have a positive or negative charge. How can we write the isotope notation for this? In order to write the isotope notation for the positively or negatively charged particle, we have to consider the following rules. 1. A particle is neutral when the number of electrons is equal to the number of protons. 2. A particle is positively charged when the number of electrons is less than the number of protons. 3. A particle is negatively charged when the number of electrons is more than the number of protons. So, for both positively or negatively charged particle, the charge will be noted on the top right of the element symbol. For instance, let's take sulfur atom. Sulfur has 16 proton, 16 electron, and 16 neutron. It can be written down as follows. On the bottom left, 16, that's the proton number. On the top left, 32, that's the nucleon number, where the formula for nucleon number is A equals to proton plus neutron, so 16 plus 16, you get 32. If sulfur gains 2 more electrons, so now we have 18 electrons, so the notation will be written as follows. As you can see, the charge is noted on the top right, so the formula to get the value of the charge is proton plus electron. So we have 16 times with positive 1, as one proton has a charge of positive 1, plus 18 times with negative 1, as one electron has a charge of negative 1. So in total, you get negative 2. But make sure you write 2 negative on the isotope notation, not negative 2. Okay? So, we just had a look at examples when the number of electrons of sulfur are different. Now, let's have a look when the number of neutrons are different. A fun fact of sulfur, it has 5 different atoms with different number of neutrons. For instance, we take one with 18 neutrons. How do we write the isotope notation for this one then? So now the isotope notation will be written as follows. For this atom, the nucleon number is 34. If the number of neutrons of sulfur is 17, so this is how we write the isotope notation. And this one is when the number of neutrons is 19 and this is 20. So if we put all these 5 atoms together, they are known collectively as isotopes. So isotopes are 2 or more atoms of the same element that have the same number of protons but different number of neutrons. A lot of elements exist as isotopes. Most commonly known isotopes are carbon-14 and sodium-24. Isotopes are important in many fields such as medicine and archaeology. This is because some isotopes of an element are unstable and have radioactive properties. For example, carbon-14 is used in archaeology for carbon dating. This is the method used to determine the age of artifacts and fossils. Whereas, sodium-24 is used for the leak detection in underground piping. Right, let's move to the last part of the video to test your understanding on this topic. Based on the isotope notations below, identify the number of proton, the number of electron, and the number of neutron. For question A, please refer to the table of relative atomic mass. You can pause this video, try the question, and click play when you are ready. You may now check your answers. In this video, we have described the subatomic particles in an atom and how they can be represented in isotope notation. From isotope notation, we can extract information such as number of protons, number of electrons, number of neutrons, and charge, if any. We have also learned that atoms exist naturally as isotopes, where they have the same proton number but different nucleon number. Hope you have enjoyed this video. Don't forget to like, subscribe, and share, and click the bell icon if you want to be notified when our new videos are uploaded. Annyeong!